systems more as an integrated thing, and I might do that going forward. But for the first week, I wanted to just kind of actually look them over and kind of get a gauge on everyone's foundations. So you guys, at the bottom of these two homework, or these two packets, both of which are available on the Blackboard, there are going to be homework problems here. So you just write them up and then submit it as a PDF. So yeah, write it up, scan it, submit as a PDF. Any questions about that?
Yeah, do you care if we like type onto the document, like, or like, do you want us to print it out and like handwrite it?
You can type onto the document if that's what you prefer. Just make sure that you provide enough information that I can figure out what your thought process is. Don't just literally write the answer.
Yeah. Okay, cool, thanks.
Cool. So today we're just going to go over lines and slopes. Here's a nice little list of the key concepts. And so most of you guys probably remember or have at least seen this definition right here for how you can figure out the slope of a line, right? So this is rise over run. So this is how much your y value, or like how much you've changed vertically over how much you've changed horizontally. So that's why we call it rise over run here. So it comes here already done. So you can pick either one of these to be your x and y1 or your x and y2. So in this case, we went with this is our x2, y2, and this is our x1, y1. And then we just plug it in to the equation here. So we have 2, so that's our y2. Our y1 is equal to 0. So, sorry, y1 is equal to 3. Our x1 is equal to 0. And then our y2 is, or x2 is equal to -2. x1 is equal to 0. So then we plug that into our original equation and we get -1 over -2, which is just +1/2, right? Similar setup here. So I'll do this one for you guys, and then somebody give me the answer to this guy right here. Sorry, how about if we write it down and took a picture of it and turned it in? That is fine, just please turn it in as a single document. So if you like want to take the pictures and put the pictures of the various homework questions into a Word document, that's fine, but it just makes it a lot easier to grade if you have everything both in order and in a single document. That was answering a Wad's question right there. So here we have, let's call this x1, y1, and x2, y2. So we have 3 minus 6 divided by 0 minus 6. So it's going to be equal to -3 divided by -6 is equal to +1/2. And you could have also, like, it doesn't matter which one of these we pick to be our 1.1 and our 0.2. So if we wanted to, we could have done the opposite. We could have done 6 minus 3 divided by 6 minus 0. That's going to still be equal to 3 divided by 6 is equal to 1/2. Cool. Somebody walk me through this one.
I could do it.
Cool, thank you.
Right. So if it's rise over run, would it be 5/2 minus 3 over -1 minus 0?
Yeah, that works perfectly.
Okay. And then, so 5/2 minus 3 would equal 1/2.
I
Negative
think we get,
1/2.
yeah,
Okay, yeah, -1/2.
you're good.
And then -1 minus 0 would be still -1, right?
Yep,
And then divide -1/2 by -1, you would get +1/2.
perfect. So we got a lot of different points that have 1/2 as their slope. You can in fact have other slopes too. But so if we want to find the slope of this line, so we can check it and we can see, okay, this goes through, sorry. So we want to find the slope of a line that contains 0, 0, and 3, 5. So probably the easiest way to do this is 5 minus 0 and 3 minus 0. So what's that going to give us? Just 5 over 3, right? What does the slope mean? So this graph is attached to this question, not to the original one, not to the part A. So can someone, in your own words, give me like what the slope is? So we give it a lot of different names. Kind of one of the most frequent things that we call it is rise over run, right? But like maybe the most kind of another thing we call it is like the rate of change, right? So if you guys go on to take calc, you'll be talking about the rate of change a lot. If you want to use kind of a more physical analogy, you can talk about it as like the steepness, because if you were like climbing up this would be a very steep hill to climb up, right? So there's lots of different analogies that we can give, but does that make sense to people?
Makes sense.
Cool. Yeah. On the most basic level is how much does your y value change over how much does your x value change? But there's lots of ways to think about that. So a horizontal line is any line such that the slope is equal to 0, right? So in that case, if the slope is equal to 0, you can have something like this, where let's say this value is 2. In this case, what would describe it? It would be y is equal to 2. You could have that for, let's say this is -3, then you have y is equal to -3. And that's the equation that defines this entire line. So if you remember, we'll jump into this again in a second, but we've got y is equal to mx plus b is one of our ways that we write the equation of lines a lot. And if we have m is equal to 0, then we would have that's equal to 0x plus b, but that's just going to be equal to b, right? So, and this just means that any 2 points, like if it, going back to the 0 is how much the y value changes as the x value changes. So as the x value goes off over here, your y value has not changed at all. You have a similar concept, but it's kind of flipped for vertical lines. So for a vertical line, got something like this. Well, if I would try to describe the slope of this, it would be a little bit weird because it goes off infinitely high and infinitely low without the x value changing at all, right? So that means that like we can't really talk about the slope of this. It's kind of positive / negative infinity, but like that's not how we not how this really works. We can't just put in infinity as a coefficient. So what we have is this is just x is equal to a. So let's say that this is x is equal to 5, then we would have x is equal to 5 defines this, because the thing that is constant throughout this entire thing is your x value for a vertical line. Your x value doesn't change at all, even as your y value spikes off to positive at negative infinity. Does that make sense?
I think it could.
Cool. So we get, for horizontal lines, we get y is equal to a constant. For vertical lines, we get x is equal to a constant. Yeah. So comes pre-built with a couple of examples there. So if you want to show that it's going to be horizontal or vertical, well, horizontal, that kind of makes perfect sense, because we just have that is m equals 0. So we can plug that in to our kind of classic example, and we'll see, or like our classic equation for finding the slope of a line, and we'll just get 0, right? Another easy way to see this is we've got two different points that both have the same y value but have different x values. So if you see that, it's definitely going to be 0. It's definitely going to be horizontal, or your slope is going to be 0. For this, if we try to plug this in, then we would say this minus this, so 3 minus 1 divided by 4 minus 4, right? This minus this. So that would be 2 divided by 0. What happens when we have something divided by 0?
Is it undefined or equal to 0?
Yeah, it's undefined. So it's kind of spikes off to infinity, kind of doesn't spike, kind of spikes off to negative infinity, but it's going to be undefined. So that's another way of thinking about it being a vertical line where your slope is undefined. Another thing, just like we set up here, if you have you have the same y value, but you have two different x values, it's going to be flipped for this. So you have the same x value, but two different y values. So that's going to be enough for you to say, okay, that means that this has to be a vertical line. Cool. Yeah, so there are a few things that couple of points that we often like that make things nice and easy. One of them is the y-intercept, or the point where it crosses the y-axis. And the other one is the x-intercept, or the point where it crosses the x-axis. And those have these as their forms. And one of the reasons we really like having the y-intercept is kind of the nicest equation of a line, nicest version of the equation of a line to work with is this one right here. And that's called slope-intercept form, because we have the slope and we have the y-intercept. And this is entirely defined by those two things. Cool, does that make sense? So. Okay, so we want to find the equation of a line with a slope of m equals 2 and the y-intercept of 0, 1. So this is our y-intercept because our x value is equal to 0. So that tells me that this right here is the b. This right here, we already know the slope is m, that's equal to 2. And so using slope-intercept form, we would just get y is equal to 2x plus 1. Right? So that's enough to define the equation. But if we were to want to like actually draw this out, we would probably want to pick a couple of extra points. It's generally nice to have a couple of points. You know, if you've got your ruler and you want to line it up going through these 2 points, and if you have a third point, it'll just make it even. Like the 2 points define the line, but it can be nice to have some extra check to make sure that you're keeping everything straight if you're drawing things by hand. So we can do this if we were to do y equals 2x plus 1, and we were to plug in the point, say x equals 1 or -1, then we would have y is equal to 2 times -1 plus 1. That's equal to -2 plus 1 is equal to -1. So that defines this point right here. If we were to plug in 1, then we would have y is equal to 2 times 1 plus 1. That's equal to 2 plus 1 is equal to 3. That gives you this guy right here. And you can also just notice, okay, I step up by 1, that means I add 2, and that's because the slope is equal to 2. So when I jump from 1 to 2, I go from 3 to 5. When I go from 2 to 3, I go from 5 to 7, etc. So another thing that we can do is if we have the slope and a point, then we can find it like that is enough information. So either if we have 2 points or slope and point, that's enough to define the line. So either 2 points or a slope and a point. So what we have here, we've got a slope and a point, and we're about to jump in and talk about point slope form, but we can actually do it with the information we already have, right? So we've got y is equal to mx plus b. So I don't know what b is. This is a question mark. I do know what m is, and then I have an x value and a y value, right? So I can do 4 is equal to 5 over 3. That's my m. So this is my y, my m. My x is going to be 6 plus b. So this times this becomes 10. So we have 4 is equal to 10 plus b. And that is going to mean that b is equal to -6. So I would have y is equal to 5 over 3x minus 6. Does that make sense?
Can you repeat how you got to 10? So
that is, so if I have 5 over 3 times 6, that's going to be the same thing as 5 times 6 divided by 3.
yes.
This is 2, so that's going to be equal to 10.
Okay, thank you.
Cool, no problem. Any other questions? Cool. Well, we can also use something called point slope form, and that'll also give us the equation of a line. So we have y minus y1, or let's scroll up and actually have both of these. So if we were to do that, then this becomes our y1, sorry, this becomes our x1, this becomes our y1. So if we were to do that, we would have y minus 4 is equal to 5 over 3 times x minus 6. And then we could rearrange that to get we should be able to rearrange this to get the same thing that we had before. So if I distribute this right here, then I would get this is equal to 5 over 3 minus 10, for the same reason that we got 10 before, is equal to y minus 4. And then if I forgot the x here. Sure. Nubong, is that how you pronounce it?
Yeah. Yeah, I know. Yeah. I just had a quick question. So is it like we're choosing a different method of doing it, or
Yeah,
we,
they're two equivalent methods, but they like you've done through a few different steps, but they end up giving you the same thing. And I'm kind of just trying to show right now that they give you the same thing.
okay, thank you.
Sure, no problem. So we add 4 to both of these guys, and we get y is equal to 5/3 x minus 6. So even if you were to start doing this method, and like this is a perfectly legitimate version of the equation of a line. It's in point slope form, but you could rearrange it to get you back to slope intercept form. So, so if we want to, also if you're just given a point and a slope, like you can jump right into like this is, it doesn't require you to actually do any math. You can just kind of plug everything right in. So it's a bit quicker, even if it kind of hides a bit of the information. So we want to find the equation of a line that contains both of these points. So what's my first step going to be?
Would it be to find the slope?
Yeah, that's what I would do first. So if we wanted to do that, let's do, say, -2 minus 3 divided by 4 minus 2. So that would give us -5/2. And then we can pick either of these points. I'm going to pick the first point. And we can just toss that into, let's say, point slope form. Because it'll end up being a little bit easier. So that'll be y minus 3 is equal to -5/2 times x minus 2. Cool. If you wanted to get it into slope intercept form, we could do that. We could just distribute this, so we get -5/2x plus 5. This becomes, because we have negative times a negative, and the 2 cancels with the half. So we add 3 to both sides, and we get y is equal to -5/2x plus 8. So either this or this. If it says just put the line, like give the equation of the line, you can give either. If it says give it in point slope form, do it this way. If it says do it in slope intercept form, do it this way. So this guy, we can, what's people's first instinct?
Find slope.
Okay, we can do that. So if we do that, we would do, say, 1 minus 1 divided by 12 minus 0. So that's 0 divided by 12. That's equal to 0, right? So Anubong, do you still have, do you have another question? Is your hand just still raised from the first?
Oh, sorry, it's still raised from the.
Okay. Cool, no worries. So we have that this guy's equal to 0. What does that tell me?
That is going to be a horizontal.
Yeah, exactly. It's going to be a horizontal line. And what is my b going to be?
1.
Exactly, right? So this is just going to tell me that y is equal to 1 because we have, this is the b. So if it's a horizontal line, it's just going to be the same y value all of the time. That should get you guys thinking about something for this next problem. But what's people's first instinct for this?
to find the slope.
Okay, if we find the slope, then we do, let's say 1 minus -5 divided by 4 minus 4. So it's going to be equal to 6 divided by 0. And that is going to be undefined, right? So if it's undefined, what does that tell me?
It's vertical.
Yes, exactly. So this one right here was horizontal. This one right here is vertical. And what's the equation going to be? Just going to be x is equal to a, right? Where x is, or a is just whatever x value we've had, right? So that's just going to be 4. X equals 4, right? Because that's the x value we have for both of these guys. And if we have a vertical line, the x value does not change at all, regardless of what the y value is. Does that make sense?
Yes.
Okay. So, pardon me. So the x value, when the line is undefined, it will just be the x value because it's always constant.
Yeah, the x
Okay.
value is constant, and then like, so this is saying, okay, how does the y value change based on the x value changing? But the x value doesn't change at all, and that kind of makes sense of why this is undefined.
Okay, that makes more sense. Thank you.
Cool. So if we want to put this equation into slope-intercept form, we can rearrange this a little bit. First off, what are we gonna? What's people's first instinct for how to rearrange this?
Y equals mx plus b.
Yeah, that's the final form that we want to get into, right? So how do, like, what's the first thing that we should do to get that?
Move -3x.
Exactly. So we want to add 3x to both sides to get it over to the other side. So then that gives us 4y is equal to 3x plus 2. And now, to finish things off, we don't want 4y, right? We want just regular old y. So we're just going to divide both sides by 4. So that gives us y is equal to 3 over 4 x plus 1/2. So that's 2 over 4, which is equal to 1/2, right? So what is the slope here?
3 over 4.
Exactly. 3 over 4. And what is the y-intercept?
Would it be 1/2?
Basically, but the y-intercept is going to be a point.
The point. Okay.
So the x value of the y-intercept is always 0.
0. Okay.
So if like to actually write this as a point, it would be 0, 1/2. And kind of as a flip, what is the x-intercept? Well, the y value of the x-intercept is always going to be 0, right? So we have 0, comma, or something, comma 0. And if we want to figure out what the x-intercept is from this, we just set y equal to 0, and we see what our x is. So we get 0 is equal to 3 over 4 x plus 1/2. Let's move this guy to the other side. And we get -1/2 is equal to 3 over 4 x. And now let's multiply both sides by 4 over 3 to cancel this. So this cancels with this, and we're left with 2 here. So we get -2/3. Does that make sense to people? So this is the x-intercept. Yes, no, maybe?
I think so.
Cool, thank you. Okay, so parallel and perpendicular lines. So if we have two lines that have the same slope, or if they're both vertical, because remember the vertical lines don't really have a defined slope, but if they're both vertical, right, they're going to be parallel. So if we have the same slope. So like what's people's intuitive definition of a parallel line?
It's the same, going the same direction.
Yeah, they go in the same direction. Another thing that often gets brought up is they'll never intersect, right? No matter, like, there's no value that they'll intersect at. Perpendicular lines are going to be lines that intersect at a right angle. So if we get that this guy right here is a right angle, then that means that these two lines are perpendicular. So how do we check that these two things are, or how do we check if two lines are parallel or perpendicular? Well, if they're parallel, that means they'll have the same slope, or they'll both be vertical. And if they're perpendicular, either one of them is vertical and the other is horizontal, or they are negative reciprocals. So what does it mean for them to be negative reciprocals, or their slopes are negative reciprocals? So what does that mean for them to be negative reciprocals? So if we had y is equal to 2x plus 3, and we had y is equal to negative 1/2 x plus 2, well, this times this is going to give me -1, right? So they're reciprocals because 2, you flip it over, you get 1/2, and they're negative because, well, one's just the negative of the reciprocal of the other. So if we flip it and then make it negative, that means that they're going to be perpendicular to each other. If none of that holds, then none of it holds. So let's just take a few examples, take a few looks here. So what's people's first instinct for this?
Rewrite it.
Yeah, okay, we can rewrite it. So if we rewrite it, let's add the 3y to both sides on both of these. So that gives us 4x is equal to 3y minus 15, and 4x is equal to 3y plus 6. Let's move these guys over too. We got 4x minus 6 is equal to 3y. We had 4x, sorry, plus 15, minus 6. Minus 6 here is equal to 3y, and divide both sides by 3. We get 4 over 3x, y is equal to 4 over 3x plus 15, and y is equal to, sorry, 15 over 3 is 5, 4 over 3x minus 2. So are these parallel, perpendicular, or neither?
Parallel.
Yes, they are parallel because they have the same slope. Both of them are 4 over 3. And turns out we don't actually even have to go through this whole process. We can look at this and just say, okay, they've got the same coefficients, including where the negatives are, on the same side of the equation. That's going to be fine. We didn't actually have to jump through all of these hoops to get them into nice slope-intercept form. As nice as slope-intercept form is, we could have looked at this and said, okay, they're going to actually be parallel. Any questions? No? Cool. Okay. What about this guy right here? What's people's first instinct?
Same step.
Yeah, let's move things around and get it back to. Wait, what did you say before? Did you say same steps as before? Okay, well, we can do that. We can do 3y is equal to negative 2x plus 6, and 6y is equal to negative 4x. Now we've got everything pretty close. We just need to divide both sides to get the y's by themselves. So we got y is equal to negative 2/3 x plus 2, and we get y is equal to negative 2/3 x. So what's that going to say? Got the same slope for both of these guys, right? So they're parallel. You guys take some time, do the next two of these.
Oh, can something even be done to them? Or
I mean, you might get that they're neither, but you can definitely manipulate them to kind of see what's going on here. In fact, this second one should be pretty immediate, right? They're both already in slope-intercept form, so what do you get there?
y
Parallel?
equals
Yeah, they're going to be parallel because you've got the same slope, so they're parallel. This right here, you can rearrange it, you get 2y equal to x minus 6, and then you get 3y is equal to negative 6 plus 12, 6x plus 12. Divide both sides. So you divide this one by 2, you divide this one by 3 on both sides. If y is equal to 1/2 x minus 3, I guess. And then this one you get y is equal to negative 2x plus, sorry, yeah, negative 2x plus 4. So what is this? Is this parallel, perpendicular, or neither?
Perpendicular.
Exactly. Perpendicular because we have negative 2 times 1/2 is going to be equal, so 2 times negative 1/2 is equal to negative 1. Cool. So this becomes perpendicular, which is sometimes written that way. Try your hands at F and G quickly. Sure. These you don't actually have to rearrange at all, so I'll just ask. So we have 4 and negative 4 as our slopes. What does that tell us? Are they odd, even, or neither?
Perpendicular.
perpendicular.
Ooh. What's the definition for, or how do we know it's perpendicular?
Oh, they're parallel.
Not parallel either, right? Because we've got the negative.
Oh, right.
So if they're parallel, they'd have the same slope, right? And then if they're perpendicular, then you would have, so like what's perpendicular to 4? It would be negative 1/4.
Yeah. Okay, that makes sense.
These guys are going to be neither in the end. And then if you were to draw them on the graph, you would get, so this guy would be 2 and something like that, and then this guy would be 5 and something like this. So this is not going to be either perpendicular or parallel. What about this one?
Would that one be perpendicular? Because
Not quite, because we've got negative here and negative here. So they're reciprocals of each other, but we need negative reciprocals. Does that make sense?
yeah, I see.
So, so if we were to draw these guys, we would get one of them. So this guy is going to be 3, and we'll have like that, and then this guy is going to be 2, and he'll be something like this. So this also is not going to be perpendicular or parallel. So I'll just pick one word problem here. Does anyone have a preference on which one? And we'll do the first word problem. So a family is paid $52.50, or family paid $52.50 for water in January, and they used 15,000 gallons of water, and $77.50 in May when they used 2,500 gallons of water. So we want to find the equation of the slope that gives how much they're charged in terms of the gallons used. So first off, how are we going to order these? Like, what's going to be our X, what's going to be our Y?
Would it be the amount of gallons?
As our X or as our Y?
I'm sorry, would the amount of gallons be our Y?
I think we want to use it as our X, right? Because as we change the number of gallons, normally we think of ourselves as like ranging over the X, right? So if I say this, like I range over the X and that gives me a new Y value. I think what we want to do is we want to range over our gallons and then have that spit out how much we're going to get charged.
Okay.
So think of our bill based on how much we use. So for that, we'll have 15,000, comma 5250, and 25,000, comma 7750. So if we do this, then we get, let's say, 7750 minus 5250 divided by 25,000 minus 15,000. It's going to be equal to 25 divided by 10,000. So this is $25 per 10,000. So that's also equal to 1 divided by 4. Wait, so if we do 25 over, we have the 0, 1 divided by 400. So this is $1 per 400 gallons of use. So we could line this up, pick either of these points, and then we would get to do divided by 400 times, let's do G plus B is equal to like the dollars paid. Like this is the general form, but we don't know what that is. We can just plug this in with pick one of these 2 points, right? So this one looks like it might be a bit nicer to work with. So if we do 1 divided by 400 times 25,000 minus 7750 is equal, oh, sorry, this should be X, right? So sorry, crap, that not supposed to erase all of that, but so we want X minus X naught, so is equal to Y minus Y naught. So in this case, we get that this is equal to Y minus the 7750 is equal to 1 divided by 400 times X minus 2500. And you could rearrange that. We already have this is the slope. You could rearrange that a little bit to find out if you were to put this into slope intercept form, which I'm not going to do just because I don't really want to waste the time with doing all of the calculations. But if you've got a calculator there, it should be pretty easy to figure out how much so if you have Y is equal to MX plus B, that's how much you pay. This is how much you pay per unit, and then this is how much you pay just to get the service. So you might have to pay per gallon and also say $50 or whatever you would get if you were to actually figure this out as like a basic service fee. Does that make sense to people?
Okay, I think it's making sense.
Okay, cool. Do you guys want me to do one more problem for you guys, or do you want to just get out 2 minutes early?
Can we do another problem?
Okay, sure. So a baker then costs you. Okay, let's do number 8 here. The annual fixed cost of owning a sedan is $4,462. Maybe that's how much you have to pay for registration and annual checkups at your mechanic and blah, blah. And the cost to drive per mile is 17 cents per mile. So if we were to draw this, or if we were to write this as a line, we would have C, that's the cost for this whole thing. So it's going to be, how much are we paying per mile? Well, that's going to be 0.17 plus our fixed price, that's our B, sorry, X, 4462. So that's a very quick one, but I'll do one more. I'll do number 7 too. Sorry, the distance formula is given at the top. I don't think we actually used it at all, but it's just going to be, so the distance between these 2 points is going to be the square root of the distance between the X values. So let's do that as 2 minus -1 all squared plus 3 minus 0 all squared. So this is going to be 9 plus 9 square root. So it's going to be equal to the square root of 18 is the distance between these 2 points. So you can find that at the top of the page, but I'll very quickly do this one. So it costs $6,000 to produce 1,000 loaves of bread per day and 5,950 to produce 9,500 loaves per day. So we want to find the equation per loaves of bread. So this is going to be cost, and this is going to be our X. So we want something like this. I don't know what just happened with my computer. Okay, I'm going to write this as text because it's no longer, oh wait, is that working now? Okay, we're good. So we've got plus B. We find M is equal to 6,000 minus 5,900 divided by 10,000 minus 9 500. So that's going to be equal to 100 divided by 500 is equal to 0.2 or 20 cents per loaf of bread. And then we need, so that's what this is, 0.2. And if we were to just plug in, let's say this one, we would get 6,000 is equal to 0.2 times 10,000 plus B. So this right here is going to be equal to 2,000 plus B is equal to 6,000. So that means that B is going to be equal to 4,000. So C is equal to 0.2x plus 4,000. Sorry to go slightly over, but